Good morning and welcome to the first section on C3. Now topic C3 is all about bonding. To do this topic you really need to understand about the structure of an atom. If you can't remember about the structure of an atom, so that's protons, electrons and neutrons. If you can't remember that, go back and watch the C1 video to revise it before you have a go at this. It'll make far more sense that way, okay? So the first section of C3, bonding, we're going to do about ionic bonding. So this group here, group 0, the noble gases, if you remember from C1, these all have full outer shells of electrons. They've got no more spaces. Now all the other elements all react to try to become, in terms of electrons, like these, like the noble gases. They're trying to have the electronic structure of a noble gas. Okay, so let's draw the structure of some atoms and have a look at their electrons because it will make more sense that way. Okay, so let's draw helium first of all. Helium has 2 electrons. It's the electronic structure of 2. And lithium has 3 electrons. So it has 2 in the first shell and 1 in the outer shell. So it is 2, then 1. Now, helium. This shell here is full. It only holds 2 electrons and it has 2 electrons in it. It is completely full. So it's stable. It's not very reactive because this shell is full of electrons. Now lithium, this inner shell, its first shell is full. It has 2 electrons. But this shell, the second shell, is its outer shell. And it only has 1 electron in there. Now this shell holds 8. So that means there are 7 spaces in this shell. So this element, lithium, could do one of 2 things. It could gain 7 more electrons to have a full shell, or it could lose this one. Now which do you think is easier? Gaining 7 or losing 1? Okay, so it's going to lose that 1 electron. Now if it loses that 1 electron, it will become lithium with those 2 electrons. Now I don't draw another shell because it's lost this electron. Lithium is now 2. So lithium now has the electronic structure of helium. It has 2 electrons. But if you remember from topic C1, it's lost an electron, so it now has a charge. Now in C1 I described electrons as being a little bit like disgusting, horrible, slimy teddies. Ugh. So if it's got rid of one of these disgusting teddies, it's going to be feeling positive. Okay, so it's 1 positive because it's lost 1 electron. Now to finish off this drawing, we have to put square brackets around it to show that it's an ion. So the lithium ion has a positive charge and an electronic structure of 2. And it has just that 1 shell. Okay, let's have a look at another one. Okay, now let's look at beryllium. Beryllium has an atomic number of 4. So it has 4 electrons. 2 on the inner shell and 2 on the outer shell. So it's 2, 2. Now beryllium again, this shell needs to be full. So it can either gain 6 or lose 2. And again, which is easier? Yes, you're right. It's easier to lose 6 than gain 2. And yes, you're right. It's far easier for beryllium to lose these 2 electrons than it would be to gain 6 more. So beryllium, we draw that 1 shell with 2 electrons on it. Put my square brackets round. Now how many of those electrons or how many disgusting smelly teddies has it lost? Well, it's lost 2. So this time it's 2 plus. and it has, oh, I almost got it wrong there. It has 2 electrons, so its electronic structure is 2, and that was my mistake. Let's have a look at another one. Now let's look at a trickier one. This one's aluminium. So aluminium has an atomic number of 13. So 13. So it has 2 on that shell. It has 8 on this shell, and it has 3 on this shell. 2 plus 8 is 10, plus 3 is 13. So it's 2, 8, 3. So what do you think aluminium is going to do to become an ion? Yes, it's going to lose those 3, because that's easier than gaining 5 more. So aluminium will have 2, and then it will have 8. Oops. And it needs square brackets. It's 2, 8. And what number will we write here? How many has it lost? It's lost 3, so it's 3 plus. So this is how we draw positive ions. So now let's have a look at some negative ions. We've got fluorine. Fluorine has an atomic number of 9. So it has 2, and then it has 7. It's 2, 7. Now this time there's 1 space. So is it easier for fluorine to fill that 1 space or to lose these 7? Yes, it would be easier to fill this space, wouldn't it? So fluorine becomes the 2, the 7, and then it gains 1. Now in these dot and cross diagrams, when we gain 1, we draw the one it's gained to look slightly different. So a dot if we've drawn crosses, or a cross if we've drawn dots. Again, we put square brackets. Now this time it's gained one of these disgusting, horrible, slimy teddies, one of these electrons. If it's gained 1, it will be negative, and it'll be -1. Now before it was 2, 7, so afterwards it will be 2, 8. Let's draw another one. Let's look at sulfur. Sulfur has an atomic number of 16. 16 means 2, 8, 6. And there's 2 spaces. So 2 spaces, is it easier to fill those 2 spaces or lose the 6? That's right, it's going to fill those 2 spaces. And when it fills those 2 spaces, it's still going to have these 3 shells. 1, 2, 3. 2 electrons on the first shell, 8 electrons on the second shell, the 6 original ones, and then 2 new ones that I'm going to draw in with dots. Put my square brackets around. It's gained 2 disgusting smelly teddies, or they'd make you negative, they'd make you a bit sad. So it will be 2 negative, and this time it will be 2, 8, 8. So now we can draw negative ions and positive ions. We need to link these 2 ideas together, because if fluorine is going to gain this electron, it needs to gain it from something. And if lithium is going to lose an electron, it needs to give that electron away to something. So what could lithium give that electron away to? Or what could fluorine gain an electron from? That's right, lithium will lose 1 electron and it could give it to fluorine. So the lithium and fluorine would react. They'd react to form an ionic bond. So we're going to draw that ionic bond now. Okay, so we're going to react lithium and fluorine. I'm going to draw exactly what we did before. So lithium has an atomic number of 3. So that's 2 then 1. I'm going to react that, I'm going to write a plus, with fluorine. Fluorine has an atomic number of 9, so it has 2, and you'll notice I've done crosses here, so I'm doing dots here. It's got 2, and then 1, 2, 3, 4, 5, 6, 7. 2 and 7 adds up to the atomic number of 9. Now we need to draw our answer. So what happens now? Well, the lithium is going to form an ion. So the lithium will form will it form a positive ion or a negative ion? It was 2, 1, now it's 2, so it'll be a positive. And next to it, let's draw my fluorine, which needs 2 shells. This one needs 2 electrons. This one needs the original 7. And it needs the 1 cross from lithium. And this one gained an electron, so it's negative, and it's 2, 8. And that's how we draw an ionic bond. You'll notice we have a positive, we have a negative, and an ionic bond, it's a bit like magnets. So the positive attracts the negative, and that's what holds it in place. So that positive and negative holding it in place, we call that the electrostatic force of attraction. And as I said, it's just like magnets. The positive end of a magnet attracts the negative end of a magnet. The positive ion attracts negative ions. It's an electrostatic force of attraction. Okay, it's quite a complicated phrase for an idea that we know and we accept and is really simple. Because you know that a positive magnet, positive end of a magnet, the positive pole will attract a negative pole. You know that. And now we're just giving it a posh term, the electrostatic force of attraction. I'll keep repeating that to help you to get it in your brain. I'm going to do another one. We're going to do sodium reacting with chlorine. So sodium and chlorine. I want you to pause the video. I want you to have a try at filling this in. Give it a go and then check your answer with mine. Is this what you got? Sodium is 281, chlorine 287. The sodium ion 28 and the chloride ion 288. Now you'll notice I said the name slightly differently. Chlorine is an atom, it's 287. Over here, when it's an ion, when it's reacted, it's formed a bond, it becomes chloride. The name changes to show that it's reacted. So chlorine becomes chloride. Now in those two examples, we had lithium reacting with fluorine, and we had sodium reacting with chlorine. So when we form ionic bonds, a metal reacts with a non-metal. So we always have something from this side reacting with something from this corner. So lithium is a metal and it reacts with fluorine, a non-metal. Or in the second example, sodium is a metal and chlorine was a non-metal. So we always have a metal and a non-metal if it's forming an ionic bond. And remember, an ionic bond is that electrostatic force of attraction between the positive ions and the negative ions. The electrostatic force of attraction. Now we're going to have a go at a trickier one. We're going to react calcium and chlorine to make calcium chloride. So first of all, I want you to draw the calcium, the atom of calcium. You have a go now. Pause it and have a draw of calcium. So we've got a calcium atom. The calcium is 2882. That's 2, 8, 8 and 2. Now chlorine. Again, pause the video and draw chlorine. That's right, chlorine is 287. 2, then 8, then 7. If you've done your dots and crosses the other way around to me, it doesn't matter. Make any difference. You just need to be able to show that one set belonged to this and the other set belonged to the other one, just so that you can see where all the electrons were going. Okay, now calcium. Calcium has 2 electrons on its outer shell, so it wants to lose 2, doesn't it? Chlorine has 1 space in its outer shell, so it's going to gain 1. I'm going to draw some arrows. So this one here can go over here and form a... so this one's now full. This one would become 2, 8, 8. But what's happened to my calcium over here? My calcium is now 2, 8, 8, 1. This outer shell isn't full. It's still got 1 electron sitting there. What could I do with this 1 electron? I can't give it to this chlorine because this chlorine's full. So where could it go? It can't just float around by itself. It has to go to something. So where it's going to go to is another chlorine. Let me draw another chlorine underneath. This is my second chlorine. So this electron here could go to here. And this one now goes from being 287 to 288. And my calcium has lost that one, so it's now 288. So calcium had 2 electrons to lose, but chlorine could only gain 1. So I needed to have 2 chlorine atoms to take the 2 spare electrons. Now that working out looks quite complicated. I always do my working out like that. I like to see where those electrons have gone. Otherwise I get a bit confused. Because there's so many things going on, it's really easy to get the simple things wrong and forget how to count to 8. And that's where people go wrong. They're so busy thinking about all the difficult things that we can then get the easy things wrong and we lose the ability to count to 8. So I like to do the working out and I think it helps. Now let's draw the answer. The answer is going to look slightly different than it did before. I'm going to do my answer up here. So I'm going to draw my calcium. My calcium had 1, 2, 3, 4 shells and now it's going to have 3. Oh, I hope I've left myself enough space. And these need to be dots. So that's 2, 8, 8. That's my 2, 8, 8. And it lost 2. So it lost 2 smelly teddies. Losing 2 smelly teddies would make me positive, and it would make me 2 positive. Now chlorine. Chlorine has 3 shells. 1, 2, 3. 2 on the first shell. 8 on the second shell. And then 7 crosses and 1 dot. Draw a square bracket around it. This chlorine gained 1, so it's 1 negative. But how many chlorines did I draw? I drew 2 of them, so I write a big number 2 in front of the chlorine. Okay. Now this, like everything in chemistry, has a formula. I drew 1 calcium, so it has a little number 1 after it. And I drew how many chlorines? I drew 2. Now we don't really write that 1, do we? Remember, chemists are lazy and don't really like the number 1. So it's actually CaCl2. And that would be your answer. So all this here was my working out, was my thinking on the paper. This is my answer. There's my ionic bond, the electrostatic force of attraction between the positive calcium and the negative chlorine. And it would be CaCl2 would be its formula. 1 calcium for 2 chlorine. Okay, now I'm going to go back to these 2 examples that we did earlier. So we drew lithium and fluorine to make lithium fluoride. So lithium and fluoride. So I'm going to transfer that information down here. So we had Li was plus and fluoride was a negative. Now, I'm going to show you an easy way to work out that last bit that we did on the last one, how to work out the formula. So lithium, we've really got a number 1 here, haven't we? And a number 1 here. So what I drew is I draw an arrow from the lithium to underneath the fluoride, and I write the number, and the number is 1. Just the number. I draw an arrow from the fluoride to underneath the lithium, and I write the number. Now the number is 1, and again I write just the number. I then read it going down. So it's Li1, F1. Now do we write 1s? No, we don't. So the formula is just LiF. Okay, the second one we did, we had sodium and we had chlorine, and we reacted to make sodium chloride. Sodium chloride. Sodium was a positive, chloride was negative. Let's do that again. So sodium was positive, chloride was negative. I draw an arrow. I write the number, which is 1. My chloride, I draw an arrow. I write the number, which is 1. And then I read it going down. Sodium, 1. Chloride, 1. But again, I don't really want those 1s, so it's just NaCl. And that's the formula for sodium chloride. Now I want you to have a go at drawing another diagram for ionic bonding, and it'll be a bit like this one. There'll be a lot of arrows and things. Now before you start, I want you to do the last bit first, so that you kind of know what you're going to be drawing, so that you can be double checking yourself as you go. So I'm going to ask you to draw aluminium. Okay, now using all that information, and I know there's been a lot, you can always watch this back first before you have a try, or if you get stuck, watch the bit you think is most important. So I want you to have a go at a few questions, see how you get on. There's nothing wrong with going back and watching little bits again. I want you to have a go at question 1 and 2 if you are foundation, and 3, 4 and 5 if you are higher. Now remember, as before, if you're finding the questions too easy, have a go at the harder ones. Or if the hard ones are too difficult, have a go at the easy ones first and then stretch yourself. So that's everything on ionic bonds, how ionic bonds are formed. Now just remember, ionic bonds always have a metal reacting with a non-metal, and those ions form the electrostatic force of attraction, that horrible phrase that we need to remember. So let me know how you got on with ionic bonds, and then when you're feeling confident with these, you can move on to the next section, which is covalent bonds. But make sure you can do ionic bonds first. So have a go at the practice. In fact, I'll put a second sheet up with some more practice on. So have a go at them both. Give them a good go and let me know how you get on. I'm really proud of how you're doing. You're doing really, really well. Well done. Keep it going.